Hi everybody, we're going to talk about FLN2 today, which is the area of triangles. And before we get started, I want to make a brief public service announcement about triangles. We're going to be working on right triangles, where one of the angles is 90 degrees. We're going to be working with acute triangles, where all of the angles are less than 90 degrees, and obtuse triangles, where one angle is greater than 90 degrees. And the way you can remember that is if you've ever been to the doctor and they asked you about acute pain is sharp pain, like a sharp end of this triangle poking you. Or have you ever heard someone call someone else obtuse? Not very polite, but an obtuse person is not sharp. They're dull, kind of like this big dull angle here. So obtuse, like don't be obtuse, means this angle. The opposite of sharp or acute, when something is acute, it's a sharp pain. So let's not be obtuse. Let's work on the area of triangles. So the area of triangles is 1/2 base times height. And there is a great con video that helps you reorganize triangles into half of a square to show you why that is true. So I would like you guys all to look at that video. But from here, on the FLN that we have a very basic triangle. And our first triangle was 5 by 8. Okay, with a right triangle, it's fairly easy. This is the height of the triangle. And I know this is backwards from what it is on the FLN. The FLN has actually the 8 as the base, but it's the same difference. It really doesn't remember. Remember the commutative property of multiplication, meaning that 5 times 8 is the same thing as 8 times 5. So we have these two units, and we're going to plug it into our equation. 1/2 5 times 8, right? So 5 times 8 is?
I have no idea.
40. And half of 40 is
20.
And I believe the units on this one was inches squared. So that is the first example. The next example in the FLN is actually an obtuse angle, meaning it's not very bright. No, meaning that this angle is greater than 90 degrees. Okay? So when I'm taking an obtuse angle, just like we talked about yesterday with the Sydney Opera House, I need the height of the angle. So I need to drop an altitude here that is perpendicular to the base. That's going to tell you how tall, or the height of this triangle. And so in this example, they gave us a base, and these are not really here, right? These little dots indicate that it is just a. My daughter told me that you guys know those lines aren't really there. All right, and in this example, I have 12 by 9, I believe. So again, when I do area equals base times height, I plug this into my equation. And I believe these have the units of meters. So 1/2 9 times 12. And what is 9 times 12? Well, if you forgot your arithmetic like my daughter and I, you can just do it here. 108. Okay, so then I have 1/2 108 is area.
You wrote 10.
Okay, thank you. 108. And then half of 108. Again, what is half of 108? 2 goes in
54.
10 5 times. Bring down the 8. 2 goes into 8 4 times. And I'm left with area is 54 meters squared. Box your answer. And that tells you the area of this triangle. Okay, the last example is when they're given the area and you have to find one of the missing lengths. So follow along in the FLN, guys. It says, example, a triangle has an area of 78 feet squared and a height of 13 feet. What is the length of the base? Again, we can draw a figure if we want of a triangle, and it has a 13 feet. Oh, it said height, so let's put it over here. 13 feet, and the base, we don't know. That's our unknown, our variable, right? But we know the area is equal to 78 feet squared. So first, what we do is we write an equation. Area equals 1/2 base times height. Now we fill in the equation with our knowns. So we know the area, so everywhere we see an A, right, plug and chug, we put a 78. Then I keep my 1/2. Everywhere that I see a B, I leave B because I don't know B, that's my variable. Everywhere I see height, I put 13. Now, I have an equation here that I have to solve for b, and there's many ways to skin a cat. So first, it's up to you if you want to distribute this 1/2 or if you want to pull the 1/2 over to the 78. I'm just going to distribute the 1/2. So again, with the commutative property of multiplication, I know that all of these are multiplied by each other. So I have 13 halves times b equals 78. Now, how do I get b all alone? I have to multiply it by the reciprocal or inverse. So the inverse of 13 seconds is 2/13. And I do that on both sides, right? This 13 cancels out with that 13, this 2 cancels out with that 2, and I'm left with b equals 2 times 78 over 13. And 78 times 2, for those of you like me who don't do math in our heads that well, is 156 divided by 13 is equal to b. And then my last step, what's 156 divided by 13? 13 goes into 15 one time. I'm left with 26. 13 goes into 26 two times, and I'm left with 12. And then, okay, the last step is unit analysis. So we know that area, when they give it to us, area is 78 feet squared. So I'm going to do this separately because sometimes with all the feet and the squared and then the solving equations, it gets a little confusing. And then I still have 1/2 base, which I don't know, times feet, right? This is just a constant, the 1/2, so it doesn't really matter in our unit analysis. What we're looking for is the feet. So I have feet squared. This constant doesn't have any units. B times feet. So then when I divide both sides, I take the reciprocal, right? The inverse, I should say. These cancel out. This second cancel out this foot, and I'm left with feet for B. Go ahead and look at the con. It's not a video, it's actually an article that lets you move the triangles around to split them up into parts of a square, and it's quite fun.